Hello again. I'd like to give you a quick tour of my equipment for FPGA development. First on the tour are a couple of oscilloscopes. If you have a budget only for one scope, I think I would say go with the digital scope here. This is a Tektronix 2-channel 50 megahertz bandwidth oscilloscope. And you can see it says it's 1 gigasamples per second. It's easy to use and really bright. Now, I got this analog oscilloscope off of eBay, and it has 100 megahertz bandwidth, so it's actually a faster scope than this digital scope. It's analog, and for an easy signal like this 100 kilohertz sine wave coming from the FPGA, it has no problems displaying it. But for more challenging waveforms, sometimes the analog scope actually works better, and sometimes the digital scope works better. We'll go into that in a future video. Next on the tour is this small audio amplifier, which is currently hooked up to the output of the FPGA and digital to analog converter. It's just an audio amplifier with a loudspeaker. I made this in a convenient box, and so you can hear what's coming out. You can check and see if it's working properly. Here, let's change the frequency. All right. You will need some sort of function generator. I happen to have a WaveTech that I got from eBay. It's much fancier than what you need. Anything that will make signals from a few hertz to a few hundred kilohertz would be good enough. Next up is my FPGA board. This is the Go board from NANDland, and connected to it through the PMOD port is a 16-bit 1 megasample per second digital to analog converter, the PMOD DA3 from Digilent. And now there are actually two ports here, but to be able to use both of them, you need a little splitter cable to be able to physically fit the two boards in. And the second PMOD board that I have is the AD1. It's a 2-channel 16-bit 1 million sample per second analog to digital converter. Right now, the Go board, the FPGA board, is being run by a dedicated power supply. That's optional for you, but I'll describe later the advantages of having a dedicated power supply just for the FPGA board. Now the Go board, even though it's really great for learning, it has its limitations, and you're going to run into those limitations pretty quickly. So to get past those limitations, I got a Ultra Plus Breakout board. It's from the FPGA is from the same manufacturer, is from Lattice, but this FPGA, it's this tiny little chip right here, is very capable. It has 5 times more logic built into it. It has 64 times more memory in it. It has digital signal processors built into it. The Go board doesn't, and it has a phase lock loop, which gives you the ability to vary the clock frequency, which is extremely helpful. Also, this one, the clock can be adjusted up to 50 or higher megahertz. Now, another advantage of this particular board is that it uses the same easy-to-understand FPGA creation environment, Verilog programming environment as the Go board. So if you want to take a step up from the Go board, you can go to this thing without having to learn new software. Continuing up in capability, this is the DE0 Nano learning board from Altera. Now, actually, Altera has been bought by Intel, so I don't know whether to call it Altera or Intel, but anyhow, this thing is way more capable than the Go board and quite a bit more capable than the Ultra Plus. It's also got a 50 megahertz clock. It has 1,000 times more logic than the Go board has. It has many digital signal processors on board. It has 34 times more memory. And also, it has the architecture built into it for building microprocessors. So you can implement a microprocessor in this chip and run software on the chip, which opens up a whole new world of possibilities and complexity. Speaking of complexity, you're going to have to learn a new software environment to use this board, the Quartus environment. The DE0 Nano board has on it a 2-channel 12-bit ADC. It's not super fast. It goes 200 kilosamples per second. And unfortunately, it has no digital to analog converter. So I went ahead and I got this 16-bit 50 million samples per second digital to analog converter board. It's a little inconvenient, you see. I had to solder these connectors because it requires plus and minus external power. But anyway, it works, and we'll be using that. So now, coming to the end of the tour, we're coming to the computer system. This little box right here is an Intel NUC. It's got an Intel Core i5 CPU in it. It's got 16 gigabytes of RAM, which is maybe more than I actually need. I don't think I need more than 8. I can show you that I've got the Ice Cube software installed. So that's for programming Lattice, the Go board, and the Ultra Plus board. I've also got the Quartus, the Intel or Altera programming software installed. So that would be for programming the DE0 Nano board. One last thing that I can show you is the web server from which you're getting my web pages. So I've got a Intel Atom computer. This is the power supply, and this is the disk drive that has the web pages. So that's it for the tour of hardware. Thank you for watching, and be sure to visit my website. Thank you.